My name is Eian Davis. I am one of the primary support technicians and trainers at GeoQ. And this afternoon, we will be going how to QA/QC your data in a variety of different methods in LP360. We will not be covering the entire exercise, but I will be reading out the different sections that we are covering through today's session. There we go. Perfect. All right, everybody. So you can go ahead and get your LP360 opened up. We will be importing a LAS data set, and we will start off by going through our LAS File Analyst. For those of you that are following along in the exercise booklet, we will be starting on page 53, section 0200. That is where we will be starting this afternoon. To begin this exercise, I will be adding my data using the Add Files dialog. And if you are using our sample data set for this afternoon, we will be looking for this folder. So 2025 LP360 UC LP0200 through 0240 QA/QC. Inside this folder, you should have 5 LAS files that we will be importing for our processing. I am going to select all 5 of those for my import process. So as I mentioned, we will be going through some different ways of assessing your data. So for more in depth, we'll go into the LAS File Analyst, but you can also do some assessment before you even import into LP360 by clicking this button to expand out the header information about your individual LAS files. Now, some of the attributes that will be displayed here are going to be the number of points, the overall LAS file size, the different dates regarding this data, including when it was generated, the coordinate system information, and you will notice the version and PDRF. This is going to be the point data format that is used. For any LAS data that is generated from LP360, it will be a PDRF7. This means it has the ability to store classification as well as RGB and other attributes. So it is important to understand what version and PDRF your dataset is. Now for this exercise, we are going to set this to open to read write, but to start off, we're going to first click on Load Footprint Only. Okay, we're going to load only the footprint. Once I click OK, you should notice these boxes appear on your map. That is because when you load the footprint, you are not loading the actual LAS data. You are only loading in the boundary of the outermost points. So for some users, this is intended to view the overall coverage of their LAS files before loading them in, because the LAS file may be large in size, may be difficult for your computer to handle, and at least this way you can identify the area that it resides. To load in the data, we can right-click on our LAS file and select the LAS File Analyst, indicated here. This same tool can also be activated on the project ribbon here under LAS File Analyst. Now, I would like you to take note of this column on the far side. This indicates that the LAS file has not been scanned. This means all of our point information has not been populated regarding this specific data set. You may also notice that this button is pushed in or enabled on my computer. If I disable it, as you see here, it will only display the names of the LAS files. If you enable this button here, it will display the header information. So this is the same information that could be seen in that import dialog. So as I mentioned before, you can see your points or number of points, your file size, the date it was generated, the coordinate system information, version, PDRF, pyramid type, and much, much more. These are very important for understanding your data and how it is formatted, not just the data itself. Now for the scan, so once again, I'm just going to re-enable this button. You will see these are all 0. If I select one of these files, it will enable my buttons here, and I am able to click Scan. Scan goes through and computes all of the individual attributes in this regard, so your minimum X, Y, and Z as well as the maximum X, Y, and Z coordinate for your points, your max point density, intensity, points, number of returns, your highest return, and much more information about the data that was collected. You can also perform different types of analysis, editing, and repair using the options button that you see here. If I enable this one, you'll see here on the scan tab, it should automatically select hide zero value columns, such as the returns, classes, and point source ID. Point source ID refers to the ID assigned to each point regarding its flight line used for creation. Under the Analyze option, you can choose to check these options here, which will test if this is generated as a QVR pyramid type and if it is valid. Under the LAS or LAS tab, you have many other attributes that you can enable to assess if this meets a specific threshold. So do all of these attributes read properly from the header of this particular LAS file? Under Repair, you have the ability to update your QVR file if needed. Or under the LAS, you can update any of your header information as well as repair any SRS. Now, if you are using this update option for your SRS or spatial reference system, keep in mind this does not do a reprojection. This is only intended for repairing the coordinate system history as it is associated with this file. It does not change the data in any way, shape, or form. Okay. Same with our edit here. We can enable a few different options that can be modified using this particular dialog, and that includes our point source ID. Now, if we did choose any of these options for execution purposes, so for example, if we decided we did want to analyze our data, I do want you to take note of the fact that these are highlighted in red. When they are highlighted in red, that means there is something selected on that particular tab for, in this case, analysis or for scan. I will leave all of my options enabled under my LAS tab here. Click OK. And now I am going to analyze my data. So I want you to notice how our Analyze button here has a small icon. If you look to the left, you will see the same exact icon. That means if you would like to review your analyzed attributes, you will enable this button. Right now you will see they are all 0 because I have not yet clicked the Analyze button. Once I click Analyze, it will then perform a test on every attribute that I enabled in that dialog previously seen. Now, when you hover over them, you can see this one says the QVR file does not exist. That is because our LAS file is pyramided using LP-LAS. LP-LAS is a different pyramiding style, so it is expected to see that it fails for the QVR pyramiding. If we look under our header, it is looking for the LASF header signature. In this case, it does meet this criteria. Same if we move over to our project ID. It contains all zeros. Is that the case? Yes, it will list this information, and so on and so forth. This can be done for multiple LAS files at the same time by holding Shift when you select and click Analyze. It will then sort through all of your LAS files versus one individually. Now, this is used to assess the overall attributes of your LAS. This does not necessarily mean we have an issue. It is a way of understanding your data and the header information stored within. Okay. A way we can display our boundaries here, you can see I just clicked that button and my point cloud appeared. That is because it was loading in the boundary points for these files. We also have a select graphically option that would allow you to select these different LAS and identify them. This same type of display that you are seeing here, if I close my LAS File Analyst, they can also be found on the Map ribbon. That includes the display boundaries, the select graphically, and the load and select. So if this was still unloaded, if you were still only seeing your boundary points, you can enable this function and select any of the boundaries that you would like to load into your LP360, and it will load automatically. Additionally, on the LAS Files tab, located at the bottom of the table of contents, you will navigate and see your different LAS files listed. Now, there are a few icons associated with this. The first one is the one indicating your pyramiding style. In this case, we have our LP LAS pyramiding type. If you were using QVR, it would be in a pyramid shape. This next column indicates if the data, oops, it's not going to hover now, is it? Nope, it's not letting me interact for some reason. This indicates if the data has been successfully loaded properly and scanned inside of your data set. And this is our indication, the lock icon. If your data set is open to read-write, it will be green. If it is set to read only, meaning you cannot modify or edit it in any way, it will be red. Okay. So in our exercise document, I am going to skip to Section 4 before we do Section 2. Section 4 is going to be the point cloud statistics assessment that we will be performing. Point cloud statistics can be found on the QA/QC tab. For those of you following along in the printed document, I am on page 57 for Section 4. So on the QA/QC tab, we are going to select our point cloud statistics here. For our source point selection, this data set is a little different from last year, so we do not have to have all of the same attributes selected about our data, but we are still going to choose to only review our first returns. So that means when the laser beam was fired from your scanner, whatever object it hit first will be stored as a first return, and those will be the objects we are assessing at this time. So under the Returns tab, where it says All Returns in this dropdown, I'm going to choose First Return only. Additionally, we are also going to set a filter for our scan angle. This helps us to eliminate any overlap that could be viewed in our assessment. Now, this particular data set is a UAV data set where this exercise, which was originally intended for a much larger and less dense data set, so we are going to modify those minimum and maximum values. So what I'm going to do to create this is I'm going to click the plus button. You do need to give this a name, so in this case I'm going to say no overlap, because we will be excluding any overlap points that would have been collected during this flight. We are going to continue to use the between option. In this case, I'm going to use -20 and +20. And you can either choose to leave it as your color ramp, or you can select a specific color. Now, if you wanted this to actually be filtered in your point cloud, you could do this here and save this as a filter, which would allow you to display these particular points and assess if this actually covers the points you expect it to. So I could say no overlap, and I'll call this exercise because I do have several different filters. And it will now be added into my drop-down, and I can use it for viewing purposes. So in this case, I am going to click Filter Only, and you'll see the yellow icon appears. The yellow icon in the Live View filter indicates a filter is in place. So we're going to click OK. Oops. Yes, that's fine. Since I made a change here by changing this filter only option, it's asking me to save those edits. That's okay. So I'm going to save that out. Now, under the General tab, we have a few different attributes that we are going to select here. That's going to include our point density and our nominal point spacing. We also want to extract by file. Okay. Under the point attributes, we are going to select a couple different options as well. So the first one is going to be our elevation. Under elevation, I want you to select minimum, average, and maximum. Under the intensity option, I want you to check the same options, so minimum, average, maximum. For our next two, we are going to do the return. In this case, we will only do the minimum and maximum returns detected in our point cloud. And we can also choose our GPS time. This, again, will just be the minimum and maximum. So that'll show us the beginning and end of our flight. You can also choose the scan angle option. Once again, we will do the minimum, average, and maximum options. Under the header attributes, we do want to enable all of these attributes here so that they will be included in our output shapefile. Instead of going through and clicking all of them individually, as you can see, you can also enable them all using this button. Okay. Absolutely. You're welcome. So on the General tab, once again, we are doing the extract by file, so it will calculate the statistics per individual file. And it also will include information about our point density and our nominal point spacing. Our nominal point spacing we are going to use in our next step, which is included in section 2 of our exercise, where we do a point density raster. All right. Now, I do like to shorten up this name a little bit. So I'll normally, instead of it saying this, I will just call it stats and the name of my LAS file. Or if you wanted to change the output location, you can specify it elsewhere. As I mentioned, I just like to take that off just to make it a little bit shorter, since LP360 does have a 200 character limit. That is not a limitation of LP360, that is a limitation of Windows. Shortening your project names can help keep that path short. That way you never have to worry about that limitation. You can choose to run this by your entire layer or by some of these other executable options. For my exercise, I prefer to do the by layer option. Since this is a pretty small data set, it should run relatively quickly, and you will notice a new attribute or a new feature layer has been added to your table of contents. We are now going to open the Feature Analyst to review all of the output information. So right-click on that feature layer and select Feature Analyst. Here. And we can begin reviewing that information. Now I'm selecting my first layer here, and I'm going to begin scrolling over to the right. So I can see my full SRS, which was included. So this is all that information from the point header tab that we selected. So put out our version number, our system ID, our generation software that was used. In this case, it was LP360, so it does store that information in your LAS file as well. You can also see the year, the day in the year this was generated, your point count, this is called the return number count. So this is going to be our return 1, how many points exist within there, return 2, 3, 4, and so on. We do have our minimum, maximum ranges here for our X, Y, and Z. Here's our point density and our nominal point spacing. Now it looks like those may not have populated quite right, but that's okay. And that's actually very important for testing purposes. So if you ever do notice something that doesn't look quite right, you can always reach out to us at support@goq.com and help us to improve the software so that we can help you. All right. Now that we have reviewed this information about our point cloud, We can move back into our section 2. So that is page 55 of the original exercise. This is where we are going to generate a point density image. So this helps us to visualize the point density overall of our point cloud. Now the way this is done is through the export wizard. You will find that on the project ribbon of LP360. So on the project ribbon, locate the export wizard. There are many other deliverables that can be exported through this tool, but for now we're going to focus on this one. It is a surface type export, so under type, I want you to click surface. Under our input points filter, we are going to set a few different things. So first off, we want to do the same thing as we did before, where we're looking at only our first returns. So on my return tab, I'm going to check first return. In this case, our data set has not been classified with any flags, so we do not need to set that part of this particular exercise, so you guys can ignore that. But we are going to set that scan angle like we did before. So under scan angle, I can either recreate it, or, as I mentioned before, you can save a filter. You can come here and find it. So here's my no overlap exercise. You can see both of those highlighted there along with the filter. That way I do not have to set them over and over again. Okay. So now that I have that done, I'm going to click OK. Under the surface method, we are going to change this to the point insertion option. I do want you to take note of the surface attributes when we make this change, because with each surface method, there will be different exports that can be accomplished. So under this one, we are able to select density. And typically, your cell edge length, you want it to be roughly a little bit over your nominal point spacing. So often this is going to be about 1.4 meters. Most of the time, you can also have it auto-compute your cell size based on the points that it is able to detect. But in this case, I'm going to go with that 1.4. Since this is a UAV data set, I could take this smaller, but for our general purposes, we're going to keep it at that cell size. Now, when I selected density, you may have noticed that this new tab appeared. And we do have some attributes we can set on that as well. Now on here, you can select if you would, or how you would like this to do your density. In this case, we're going to do graphic. That way it will colorize based on our point density. In this case, we are going to set this one to, let's say, 0.05. Keep it something general. You will see it modify the ranges down here, so it will indicate these different options. And you can actually modify the units used. So if I wanted to stick with meters, because my project's in meters, I could. Or I can actually use feet, and it will still calculate as intended. It will just be in that different unit. You can also change the number of intervals that you have up to 10 intervals. But for this exercise, I will leave it as 4. Okay. If you would like, for your particular cell generation, you can also get it to generate the cell shapefile that it uses to generate this new raster. I'm not going to do this for this exercise, but that option is available to you if that is of interest. Moving on to our next tab, this is how you can execute. I'm just going to talk about our different options here for a moment. So most often you are going to use the basic extent, which is the extent of the active LAS layer. Underneath this dropdown, you do have a couple other options. And if you ever want to execute a export wizard and you want to do it within a given area, so maybe you want to extract an area of interest, you can use the cookie cut by polygon. You simply need to create your feature prior to this, and then you can export data inside of any feature that you create. Okay. On the final page is where you set your output location. So in this case, I'm just going to put it underneath my data folder. And I will call it point density QA QC. You will notice it is generating a TIFF for this because it is generating a raster to display our point density based on the attributes that we have input. Once you have successfully set all that information, you can then click Finish, and it will generate your raster. It appears to have not added back to my map. That's okay. Let's see if I can locate it really quick. All image files. Well, it looks like it wants to hide from me. And it could be because I made a fatal mistake at the start. Did anyone notice I did not save my project? It'll get you every time. Yep. Oh, well, one of us was thinking ahead. Yeah. Okay. Yeah. So that is one thing in LP360. You can see even us as the specialist, a simple mistake or a simple misstep can lead to confusion later on in your processing. A lot of LP360 functions do require that you save your project before execution, or it will not know where to store your project because it is using what's called the LP360 project path variable for your export. All right, so in this case, I am going to now save my project because that's a very important step. Keep the name real simple, so just QA/QC exercise. Yes, please. And let's see if we can get this to work again. Now, I'm going to actually let it auto-compute. I'm going to let it figure it out for me. We're going to check our input points to make sure it stored all that information. So our filter only, we only want the stuff in here. Perfect. First returns. Sounds good. Density tab. This should be correct, but we're going to double check because I want to make sure I'm not missing anything else and tell you wrong. Okay, density tab. Okay. Yep. Nope, I want my graphics here. I do want to do my general extent. Now let's try this again, but I'm going to put it under my exercise. So let's find it. QA/QC exercise. And we'll call it Take 2. Click Finish. And let's see. Looks like mine does not like me today. Yep. So you can see it did auto-detect a much smaller size than I originally put in. That's because this has a much higher density than our previously generated data sets. As a quick note as well, for our conference, we do also use an experimental release, and I'm on a newer version than you guys, so please bear with me if there are any issues observed. This is an entirely optional process that we are going through today. So it's mostly to show you the different options that you can utilize during your processing for generation of QA/QC products. The most commonly used will be for relative accuracy, the point cloud statistics, and surface precision. Those are the tools we recommend most often versus the point density, but this is how you can generate it. Let's see. For the sake of keeping things moving, because it is 3:30, I am going to move on to our next section. So let me take a look at this real quick. So that's going to be my page 61 under the 0210 section. And I'm going to show you a couple different ways of creating a DZ ortho. Yes? Interesting. If that's the case, I'm going to be heckin' bamboozled. Let's see. Yeah, this is a very small data set by design so that we can run these tools very quickly. Because we also intended to have you ask questions and things like that during the training session. So funny enough, That used to be backwards. If you sent it to the job manager, it would not work. So that's very fun. Love that. Okay. So it looks like all of my density fell within that green area, meaning it had higher point density than I specified in my interval, which is what I would want to see. So in this case, this meets my entire threshold. I'm happy with these results. I can keep moving. So as I mentioned, we're going to do some DZ images. So that's now can be processed through the surface precision. So that's actually the method that we recommend to everyone. But I'm going to show you both options for that generation. So the original option is going to be through the export wizard. Again, this will be another surface type. In the inputs points filter, in this case, we're going to remove all of our filters because we do want to utilize all of our data. We don't want to be excluding anything during this process. So for here, I will just switch back to my all points, and you'll see it automatically disables those filters without me having to actually edit anything. Okay. So once we've done that, we are going to leave this as the point insertion option. But instead of density, we're going to disable that one and click DZ image. With many of our attributes, you will notice a new tab has been added to the dialog that will allow you to configure the settings. Now this one will let you modify your intervals. So in this case, if I wanted to, I could increase this one to 5. And let's say we want to do an interval of 2 centimeters versus, in this case, it's 2.5 centimeters. So we'll just decrease that slightly. So, well, actually, we're in meters, so that's going to be 0.2. That's what I want. Okay. You can modify the colors as well if you would like, because I do know that we have some individuals that may have difficulty with certain colors. You can modify those to your needs, but in this case, I am going to leave them as they are. Once again, I will run this by my entire LAS layer. If you would like to draw a boundary box or just have a single area with this executed, you can choose the draw window option. Using this button will allow you to draw a window in your map view, and that will be where it executes. If you choose to use this option, once you have drawn your window, do not touch anything outside of the export wizard. It will throw away your new window that you have drawn. You will have to draw it again. Let's not have to redo steps. But in this case, I am going to run it over my entire active LAS layer since we do have a small data set. On the final page, we are going to once again export. This will export another TIFF, but as I mentioned, this one is referred to as a DZ image, so that's what I'm going to call it, is DZ QA/QC exercise, and click Finish. The job manager can be accessed from up here at the top because I did submit mine to the job manager, so you can monitor the progress. Now the DZ image typically will take a little bit longer to execute than some of the other deliverables through the export wizard, so do keep that in mind because it is analyzing your entire point cloud for this purpose. Now you can see it is complete, so we're going to complete this job so we can review our results. Yes, here we are. So my DZ image here, highlighting areas in green that fall within that 2 centimeter range. Anything that falls outside of it or falls in a higher interval, we will see that it is colorized in red. There is another way of doing this as well that's not going to be quite as segmented as our export wizard here, and that will be our surface precision raster. Now the surface precision raster has a couple different options, so for those of you following along in the book, I'm on page 63, section 3 for surface precision. Now this tool does require additional licensing, so you need to have either the strip align, strip adjust, or the Business Intelligence Tool License, or BIT, License Add-on Product, to be able to use Surface Precision, but it can be found on the QA/QC tab right here. Now for this one, we do have two different rasters that we're going to generate. The primary difference between these is how they are colorized. So for the first one, we are going to generate a grayscale. We will be doing the global and the inter-swath. So that's going to look at areas of overlap detected in your point cloud. For our cell size, we are going to do 5. So that will be 5 map units. So in this case, 5 meters. You can select the output folder and output name. So output layer root name is just the name of whatever file is being used for import. You can see that up here on your active LAS. If you had multiple LAS layers in your project and you wanted to assess different ones, you can actually click this drop down and select the desired LAS inside of the dialog. All right. So for this, I am going to name it grayscale output. Just like that. And I'm going to continue to use the grayscale used down here. Now something else I am going to enable is the use planar surface. And the reason I'm doing this is I am going to gesture to our current export here. You can see here all of this is green. Most of the red falls on our vegetation. Now that is because while you are collecting data, vegetation is going to have some level of dynamic movement, whether it be from wind or some other external factor, so it is not going to have a rigid structure in your point cloud. Whereas roads and other such man-made structures will have that standardized look in the point cloud and make it much easier for the algorithm to detect any actual surface precise measurements. All right. So from here, I'm going to click Finish, or Process, and it should generate that output. But for some reason, it looks like mine wants to generate nothing for some reason. So let me try this again. There it is. There's the folder. Let's see. I'm getting very confused on why this is not running. Everything's enabled. Okay. Nothing out there. My advanced settings shouldn't be enabled. Okay. I think at some point today I broke my computer, but I hope the rest of you are able to run these. Okay, some individuals can run them. Okay. Yeah. I have to say this is a first because I did test this entire document before our conference, so I know these were working 2 days ago. Okay, so they are locked. Okay, so we're going to right click. So I'm going to select Open to Read Write. Nope, select. Why are you not selecting all of them? Select. Okay. Okay, let me try. So sometimes your LP360 just needs a quick restart because sometimes it can get hung up in the back end. So I'm hoping maybe that's what's going on. I do apologize for jumping around here a bit. Hopefully this will resolve that issue. Now let's try this again. So LAS Files tab. I should be able to right click on the layer itself. Open to read write. Okay, perfect. All right, select the layer name again. We're going to click load just to ensure they're loaded. Okay, that's what I want to see. Perfect. Now let's try this again. QA/QC, surface precision, global interswath, use only planar surfaces, grid cell size of 5, gray output once again, and let's give this a go. All right, now we're in business. That's what I want to see. Now you can see it is able to very easily detect all of those planar surfaces and exclude our vegetation. Because remember, our vegetation is almost always going to be flagged as a noisy surface because it has that dynamic movement. Okay. For our second example, we will be running the same settings, except we are going to choose to run it as a colorized raster instead of a grayscale, so under surface precision. I'm going to enable both global and interswath once again, but I'm going to select colorize, and just so you guys can visualize what a non-planar surface looks like in this, for me, I am going to leave the use only planar surfaces disabled just for visualization purposes, but you guys are more than welcome to set that, and this will be my colorized output. You will notice when you select the colorized option, you do have the ability to select the threshold that is used. So you can either select 2 centimeters, 5, 10, 15, 20, or set a custom one. If you choose custom, any options that were enabled at the top will allow you to specify the threshold you would like to use. For this exercise, I am going to select 2 centimeter. If you would like to see what colors will be used, you can open the advanced settings, and it will display the different colors utilized. If you would like to change the colors, you can double-click on the color icon and specify whichever color would best suit your needs or visualization purposes. All right, now with those set, I'm going to click Finish or Produce or Process, whichever button is on this one. There we are. So now I want you to take note of our vegetated areas. They are all marked in a deep red color, which means they will almost always fall outside of our threshold, especially when we're looking at very precise data, such as that comes from a UAV. So typically when you are trying to assess your point cloud for precision, you will want to use those planar surfaces for the best possible assessment. This tool is often used to detect any separation between your flight lines or discontinuity detected in a ground surface. So if you do have classified ground, you could use it for your entire data set, versus here we're using every point that was collected, which is why using that planar surface comes in handy. Okay. Now that we've looked at those, we will look at our accuracy estimation. You should have received a text file that can be imported on the control points ribbon. So on the control points ribbon, we are going to click Import and click Add. From there, in the data folder, so let me find mine just one moment, exercises, data, in the QA/QC folder, you should see a control points.txt file. Okay. Once I click Open, you will see the attributes populate in the bottom, but before we can move forward, we must specify an output location. So I'm going to click my 3 dots or my ellipse here to specify that output. So let me go, I'm just going to go up to the top level here and find my project, which is under Training, October, my QA/QC. And I'm actually going to create a new folder because I like all of my projects to be in the same format. So I will create a folder called Control Points that will have everything related to my accuracy estimation exported to this location. All right, on to our next tab. This is how you specify how your columns are divided. In this case, if we look down here, we can see there are a bunch of commas seen in our rows. So that means it is delineated by some kind of character. If your own data sets, when importing, have a header column, so for example, if this row was a header, I would want to increase this import line at to ensure that header row is not included as a record in our data set. In this case, or in this example, we do not have a header, so we can stay on import at line 1. On to the next page, we specify what character is used to delineate our different columns. In this case, it is a comma. Once I click that, you will see it snap into nice, neat rows. On the final page of this dialog is where you specify what each of these columns represent. Anything that is left as unknown will not be imported, so it is important that you do specify everything that is in here. So for our first column, we're going to have our ID field. Column number 2 is y/northing, the y/northing coordinate. Column number 3 is x/easting coordinate. Column number 4 is the z/elevation coordinate. If we scroll over here at the bottom, we can see this fourth or fifth column here is actually going to be our target type. It is very important that if you are using different types of targets that you include this in your checkpoints, because LP360 does treat each type of target differently. So if you do not have the types assigned, it cannot identify the type of target. So column number 5 is type. Finally, column number 6, you may notice it is a bunch of zeros with a few small offsets. Now in this data set, we do have some accuracy stars. These are set up at our headquarters here in Huntsville, Alabama, and they are set up on permanent poles. Typically with your accuracy stars, these would have unique values as the H offset, but since ours are on stationary poles, they do need just a small minor adjustment for that height measurement. So in this case, column number 6 is H offset. Once all of those have been set, you can click Finish. I will pause just a moment to ensure everyone is able to match their columns to mine, and it will import relatively quickly into your project. Okay. All right. Now once that's done on my table of contents, there is something that I personally like to do. So first off, I want to turn off all these other features and rasters so I can see my point cloud and I can see my control points. I personally like to change my symbology for my control points to make them easier to visualize when I am zoomed out or scaled out on my LAS. So to do that, you can double click on the symbol of your feature. I like to use the crosshair. I actually increase both the size and the weight of this particular shape, and I also select a very bright color so that it pops out against almost any background. So I typically use this pinkish magenta color here. Click OK. You will see that these become a lot more apparent against our elevation background, and they will pop out against most other backgrounds as well, so including our RGB. Now, before I actually get started doing my control assessment, I like to zoom in on one of my targets, so get to a really tight scale. I like to change my display to 10 so I can actually visualize what's over here. And if you're using black and white targets, instead of viewing by RGB, I would recommend doing by intensity. Intensity allows you to visualize your black and white targets a little better. And if I use my navigation arrows here, so previous, next, first, and last, it will allow me to drive between the different targets. Now, as I mentioned, these are our targets at our headquarters that are intended for training purposes. So some of these targets will be more easily identified than others, and that is by design, so you can see a good target versus one that has degraded over time. So under accuracy estimation here is how we're going to begin our process. If you see a pop-up like this with a yellow icon, it is not a warning, or it's not an error, it's a warning. It's saying, hey, stop, take a moment, please read me. In this case, it is letting you know that it needs 5 different fields to use your control points. In this case, it needs type, H offset, accuracy X, Y, and Z. Now, the first 2 we did import, but the last 3 will be created every single time you add in a new control point feature layer. This is because these particular fields are used for the estimation process. So in this case, I'm going to click Continue, and the dialog will appear. Now, the first setting that you see here is your survey method. This is entirely optional. The primary intended use for this would be to provide expectations for the level of accuracy for your given survey method used for checkpoint collection. So for example, if I click RTK base and rover, This is the level of accuracy in the X, Y, and Z that can be expected. This method that is selected will also be included in the exported control points file. So I'm going to click OK here. And I am going to point out a couple more things before we actually perform the assessment. So if I move this slightly over here and I select a target, it will then drive me to these different targets. So it is a way of assessing each individual target without having to navigate to them in the map view. To perform the assessment, you will click Auto Find. If you are only interested in the Z estimations, so if you are only using targets that can calculate Z and you do not have a 3D accuracy license, you can enable the Delta Z option only. You will always see this disclaimer whenever you execute this tool. All it is saying is that this report does not guarantee accuracy. It is a statistical representation of accuracy based on the ASPRS standards. Okay. So based off our first run here, we can see that our Z RMSE is 1.8 centimeters. So this is very accurate in our Z data. If we wanted to estimate our X and Y automatically, we can disable Delta Z and click Auto Find again. But this time, click OK, you will see another pop-up. That is because I have Accuracy Star, AS, Checkerboard, CB, or Concentric Circles, CO, type targets included in my control point feature layer. These 3 different targets are trained into LP360 to be recognized and auto-detected, not only in the Z, but in the X and Y as well. So they do require the 3D accuracy license. It will check it out for me if I click Yes here. As you can see, it will then perform the estimation in those 3 dimensions. Okay. Now, I do want you to take note of these colored points here. Now, colorization in this particular view is indicative of points that fall outside of a given confidence interval. So in this case, if they are highlighted in pink, it means they fall on the outer 10% of the confidence interval of this statistical measure. If they are highlighted in red, they fall in the outer 5% of the confidence interval. Now, it doesn't mean necessarily that these points are bad or inaccurate. This means you should go manually inspect these to see if maybe there are vertical objects that surround this target that could be impacting those results. Maybe the target itself has degraded over time, or there is something wrong with your point cloud. So it is important that you go and assess all of these points and not just take these statistics. So for this example, I'm looking at an FK. FK stands for full check. These are typically going to be your painted targets that will only be auto-detected for Z, but if you are able to visualize them in the point cloud, in this case it's very difficult. If you could visualize the cross of the target, you would be able to use what's called measure mode to manually select the center and calculate the X and Y there as well. You can also assess these in the profile view by drawing a profile across the given target and reviewing where the shapefile falls in relation to the LAS file. In this case, it is below the surface, so it appears our LAS file is not in the correct location for this one, so it would need to be debiased. If you would like to manually measure, I prefer to do that on my checkerboards. So here I can see that 3 of them were turned off. This means LP360 deemed these as bad targets. Apologies. If I select these targets and it drives me there and I can see my target, I can come in here, enable measure mode, and estimate that center. Now I will admit, this is the first time I'm seeing this message. This is saying that it has a duplicate control point names found. You must select a valid unique name field. It should be, but these are all be unique. Yep, typically I would call this the name and not the ID because it does have letters in here, but I was told I was supposed to select ID, so that's okay. But measure mode is available to anyone that wants to use it. You can also automatically debias your data set by clicking solve. It will calculate the estimated X, Y, and Z that needs to be shifted based on your control points. You can also take these exact same values and put them into the affine transform raster, and that would allow you to shift a orthomosaic in the X and Y as well to ensure it lines up with your point cloud. Now, typically, measure mode is most oftenly used when a orthomosaic of high resolution is coupling your LAS data set. Now, these do need to reside in the same location and coordinate system to ensure you select the correct center. From here, you can click Export Report to generate the text file from your report. So in this case, I'm going to call it my control report. And I can navigate to my folder location. So under my training, October, QA/QC, I have my control points folder and a text file here now. If I open this up, as I mentioned before, it will output a lot of different information, not just the statistics. So it includes the surface method used for measurement, the units that were used. It will actually specify what machine generated this so you can keep up with who is doing your processing. It will list the version of LP360, the date, all of these statistics that were calculated through this process. And if we scroll further down, it will summarize these statistics, including summarization of what points were used where. So as I was showing you through our report or our dialogue, there were some points that were disabled automatically by LP360 because of the quality detected there. And it will tell you all the different points that had been imported or used in this case and had been turned off. It will still give you the full measurement of those turned off points. So if I look right here, this checkerboard was disabled, but I still have the delta measurements for that particular target. Does anyone have any questions? The settings. So if you would like to modify your settings, typically we just use the defaults, but you are able to adjust these. You can do that under the settings dialog. Primarily, what you would be changing here is if you were working in an area that had some kind of vertical objects or maybe tall grass surrounding your targets, you would want to do ground classification before you did your accuracy estimation. And under your input points, you would choose only ground in that case. That would help prevent any misassessments or mismeasurements because of the surrounding, vegetation or vertical objects. The IDW. Yep. This one allows you to select a fixed radius. Typically, the fixed radius will be the size of your target if you are not using the checkerboard or concentric circle. So checkerboard and concentric circle, as I previously mentioned, are programmed directly into LP360 for automatic recognition, but there are several different targets out there. So this fixed radius can be used for any target that is imported here. It is just going to be the pyramiding method used to calculate the measurements. So the inverse distance weighted, it has more statistical analysis that goes into these measurements versus the 10, which is the most commonly used method. But I would say the IDW might have a little bit more of robust measurements than the 10 method would have. Do we have any additional questions? Well, I do apologize that this session did not go exactly as I planned. I did try to test all of these functionalities before we got here today, so it seems something changed from 2 days ago till now. But for the most part, I was still able to show you guys all these different methods. It is fully documented in our exercise document here, and we also do trainings every single month in person and online. So if you would ever like to attend and see how we QC our data sets for our TrueView units, you are more than welcome to attend those. They are free to register, so you can attend them any month. The webinars are also fully recorded, and we do share those recordings with you following the event.